Hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra and in this class we will do machining topics revision. We will be doing some uh, discussions in which we will be looking into some important formulas and important tips and tricks that you should just know to give GATE examination and to score better marks there. So before just moving forward, let me show you Unacademy's new quiz competition, Gate Combat, in which you can register by using a special code that I will be sharing with you, and also you can just see the prizes that you will get if you get good rank there. So without further ado, let's see the Gate Combat video.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So I will talk about GATE Combat while just showing you the slides. So let's do our usual introduction and talk about the benefits that you will be getting when you subscribe to Unacademy, and after that we will start our class. So once again, hello to everybody and welcome to Unacademy classes. My name is Abhishek Mishra and I have secured All India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi and I have got a good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are photo editing, video editing, cricket, football, and I like all sorts of games. So currently I am teaching manufacturing, but I will also be covering thermodynamics in the upcoming days, and I will just let you know when I will just be ready to start that thermodynamics course. So just keep an eye on the classes here. And since I have prepared for GATE examination and I have also taught it, so I will be sharing a lot of tips and tricks and a lot of things that you need to be aware of when you are giving GATE examination, so that you can score as much as marks as possible, and you cannot or you should just avoid some mistakes that will also be shown in my class. So just stick with me for around 1.5 hour or so, and just you will find that the time you spent here will be worth it. So if you are not yet following me on unacademy.com, then just follow me there, and here is the link. Just paste it or just write it down in the browser, and then you will be taken to my profile. Then just click follow me. What happens that the PDF that I am going to just teach from, and also the notes, the schedule of mine, all things will be accessible to you when you follow me there. And if you want to watch free classes on Unacademy app and website, then just download this app and use this code, or just go to the website of Unacademy and use this code. So the code is clearly visible in the screen. It is ABHIMI. So use this code to get free classes on Unacademy's mobile application and the website also. And also you can download notes by using this same code. You can join the quiz competition using the same code, and also you can get 10% off if you plan on subscribing. Unacademy's combat is one of the new things that Unacademy is bringing to the table. It is India's largest fortnightly competition for GATE. So you will have to give test or quiz every second Sunday, and you can score marks there and get a rank there, and based on your rank you can get prizes. So you are getting best of both worlds. You are getting, first of all, prizes, and second, you are also getting your preparation done by giving the quizzes or test. So it is recommended that you should just check it out. And again, to join this, to register in this, you need this code. So just remember this important code. Write it down anywhere in your copy if you need it. So here are the here is the interface of how the question will look like. So it is quite a clean and nice interface, and you will be getting the ranking in real time, and you will be competing with the best, because a lot of students are joining in this competition. So you can get an idea that where you are standing, what type of work or what type of effort you require to score good, to achieve a better rank. And it is not only just give test and move on. You are also going to be provided with detailed video solutions by top educators. So the educators who are already teaching in Unacademy for a good number of time or good number of years, they will be providing you detailed solution, so you can watch this solution and just see where you are making the mistakes or learn some new things. So it's a win-win situation, I think, that you can be having here if you decide to join this quiz or decide to register here in this quiz. And here is the whole structure of the quiz. You are going to first score, then you will be getting rating, and then leaderboard where you will see the ranks, then at last you will be getting awards based on your final rank. And here are the awards, and you can see first, second, third prizes are quite good, but top 100 rankers are also getting prizes. So these are guaranteed prizes. So if you are getting at least one of these ranks, there is the prizes shown here that you will be provided with. So Unacademy's combat is going to Unacademy's combat is going to start from December 16th, 6 p.m. So register now. Unacademy app is free to download. So to give quizzes such as Unacademy Combat, and to just learn basic classes and live classes, recorded classes, to give quizzes, all these things can be done from this app only. So I just recommend you to just check out this app, download this app from your respective app store. This is absolutely free of cost. So you can just go there and download it, and after that you can check out what features this app is offering. And believe me, this app is very, very different than anything you have experienced, anything you have seen. You will find that studying is fun again, because this app is making you do classes and quizzes in such a manner that it will feel like you are doing something very different and you are doing something very engaging. So download this app and check out for yourself, and I think you will find that this app is the best way to study, and you will just find that all your time spent here will be worth it. What you will get when you subscribe to Unacademy: daily live classes, live test and quizzes, structured courses, unlimited access. So live classes will be held daily. If you are subscribing in Unacademy today, then you will be getting live classes from the moment you have joined. You can see which classes are live and just attend one of the classes. So you will be getting your money's worth from day one, and in the live classes you can ask your doubts, answer polls, all while the class is going on. So overall, the classes here in the Unacademy is far more interactable than in the YouTube website. So the YouTube website is designed for general video streaming, and Unacademy is designed for educational purposes, mainly for that. Therefore, the educational or the teaching video quality, the teaching video quality of live features in the Unacademy's website is far better than anything in the YouTube's website. So just check out the Unacademy app and you will find for yourself how good their system is. And live tests and quizzes are also there for you to evaluate your performance with just regular test and quizzes, and you will be getting detailed analysis which you can just so you will be getting detailed analysis of the performance that you have given in a test. So overall what you will find that not only you are giving test, but you are also just getting the things that you are doing wrong, and also you are getting to know where you need to be just have more speed, and where you need to work on least and where you need to work on most. So all these things combined will make this test series that you are going to give very well worth, and you will definitely find that you are more confident and you can score better marks after giving a test. So structured courses will be there, so all the courses will be in line with the syllabus to help you best prepare for it. Unlimited access will be provided, so if you subscribe then you will be getting all these things: live test quizzes, the recorded classes, live classes, and the Unacademy combat. So all these things will be there for you to just take benefit of and prepare in a best possible manner. So it is still time, you can still get this subscription and you can still prepare 40 I think it is 1-2 months mechanical gate examination, I think 14th February. So 14th February, 2 months are there. Just join Unacademy and join crash courses and start your preparation. So this is the code to get you 10% off. Here are the prices shown. As you can see, they are very reasonable, and the prices of 12, 18 and 24 months are the one who are providing most discount. So if you have the budget, just go with it. And if you are not sure about the Unacademy's system or Unacademy's educational all the features, then you can subscribe for 1 month also, and then if you are finding it good, you can just extend your subscription. No cost EMI is available on 6 months and above subscription plan. And if you want to just get extra discount, which you totally should, just enter the code ABHIEMI that is shown on the left side of your screen. So this code will give you extra 10% discount. So make sure that you are using this code when you are going for the payment. So it is all in capital letters, and again this is price for plus type subscription, which is for those who need classroom experience, and for those students who need more assistance, it is also there in Unacademy. Iconic subscription is the name. 12 months and 24 month subscription packages for Iconic are available. They are also very reasonable priced, and again you can use the same code to get 10% off. So plus and Iconic, two type of subscription are available. Choose according to your budget and need, and start your preparation, start giving test series. 2 months there are left, so just use that time and you learn from the best resources, do crash courses, and just make sure that you are using at least this 2 months very well, so that you can score as much as marks as possible in your GATE examination. So that will be it for Unacademy's discussion about the GATE combat and the subscription. So let's move forward and start our class for the day, in which we will continue our discussion of the machining topic. So let's do that. So again, you can expect classes like this, in which we will do quick revision by a lot of different educators in the channel here on YouTube, and more specifically in the Unacademy's app and website. So just visit there and find a course and just start your preparation. So in this class today, I will do quick revision. I will only discuss the things that are going to be that will have a good amount of chance to come in your GATE examination, and that I think is very important and that I think you should not miss. So let's see what these things are. So the first thing is that we are going to discuss today. So we will have a nice relaxing discussion, but at the same time we will do it quickly. So for orthogonal cutting, this is two things that students might get confused. So the orthogonal cutting is having the uncut chip thickness is equal to d, that is depth of cut, and orthogonal turning it is having t is equal to f sine lambda. So these two things are different. Here t is equal to, let me write it here, uncut chip so t is uncut chip thickness, but for orthogonal cutting it is equal to depth of cut. And how you can just look here in this figure, let me show you that. So let me just show you the figure so that you have this proper info about what we are discussing. So let me just provide you the, let me just draw it by myself because I think that will be more quick way to do that. So this is your workpiece and this is the chip here. This is your tool. This is your workpiece. So this is the depth of cut here. So this depth of cut will be equal to t, and this is orthogonal cutting. But for orthogonal turning, take t is equal to f sine lambda. And what we know about here, not orthogonal turning, that should be only turning, because for orthogonal turning what happens, the for orthogonal turning what happens, the, so I think I have to just write it down here. Because this got, I think, permanent. So for orthogonal turning, this will become t is equal to f because lambda is 90 degrees. So simply for turning, the uncut chip thickness is equal to f sine lambda. So let's move forward and do the next discussion here in the machining topic. So I have prepared topics that I have written, that I don't forget things that I want to just inform here. So let me just tell you all these things. So the next thing that we will discuss here is if rake angle will increase. So this is your rake angle if increases, goes up, what happens? Cutting force will decrease, power therefore will decrease, and surface finish increases. So this is the thing that you have to remember. So just remember this thing because it might get asked in your GATE examination. So I want you to remember this in as much as less words possible, because again, don't just remember whole theory, just remember the thing that is coming out of that theory, and that information I am just writing here. So rake angle increases, these two things will decrease and surface finish will increase. And the next thing is the clearance angle. So the clearance angle is also known as relief angle, and it is generally 3 to 15 degrees. So remember this. And what clearance angle is, I hope you know the bottom face of the tool, the clearance or relief face, that face and the face that is machined, the new machined face or surface of the workpiece, the angle between them is the relief or clearance angle. Then we talked about in yesterday's class that I'm going to just retell here because that is important. Brass and cast iron, these materials are machined by using a tool with zero rake angle. So remember this thing, zero rake angle is for brass and cast iron workpiece. And I also talked about cutting speed. So if cutting speed or cutting velocity V increases, then you will find that power will increase and therefore temperature will go up. But FC remains unaffected or slightly reduced. Why slightly reduced? Because since temperature is increasing, then the workpiece will become soft, and due to that the force requirement will decrease. So it is reduced very slightly that we can just neglect it, but more importantly the thing that is going to be affected is cutting velocity. If increasing, then power will increase, and due to that temperature will increase, because what power is force into velocity. So if velocity is increasing, your power will increase. So let's do the next thing here. So side cutting edge angle. So let me just draw here quickly what where different angles you can see. Okay, so different angles here in the machining process, let us just look into that. So here you have, so again we are very quickly going through all the things, all the important formulas in the machining topic, all the important tips and tricks. So this is your back rake angle and this is your end relief angle. So let me just quickly do one thing here. I think there is some sort of issue going on. So let me check it out. So I think my net is working fine. Actually, some sort of working is going on inside my house, so you may experience some noises, background noises there. So apologies for that. So this is end relief or end clearance angle, and this is your back rake angle. So, or let me just draw it like this. So we have now the other angles to show, that is so this is your side rake angle and this is your side relief angle. And the last thing is these two angles, end cutting edge angle and side cutting edge angle. So side cutting edge angle is very important and we have learned about it. So these are the tool geometry and a lot of angles that you can find. And as you can see, we will mainly discuss about this rake angle, back rake angle and this side cutting edge angle. So that two are the most important ones, and let us just move forward with the discussion here. And I will also go to just show you one important thing here. So let me just tell you that thing before we move forward. The value of relief angle I showed. So now let's see the value of side cutting edge angle. So it will be equal to I think 15 to 30 degrees. So just remember that this is very important that I am discussing this value, because when you are going to get tool signatures, then what will happen, that signature will have this side cutting edge angle and other angles. So you can just know that if the tool signature is not clear, that if it is ORS or ASA. I will talk about the tool signatures in the upcoming slides. So remember that side cutting edge angle is somewhere between 15 degree to 30 degree, and if the angle is given like this around this value, then take it as a side cutting edge angle if you are not sure what angle that is. And if it is given 60 75, then that will be principal cutting edge angle or approach angle. So now let's discuss about tool signatures. So we have two tool signatures, ASA and ORS. So I will just quickly write it down, and then we will discuss what the terms are. So I hope by seeing the terms you can understand this, and you have to remember this tool signature very properly. So this thing you have to just remember, so that you can do questions when tool signature is simply given, and there are a lot of questions in which this tool signature is given. So you should just remember these things. So here alpha B is, I will quickly go through them. Alpha B is back rake angle, then we have side rake angle, then we have end relief angle, side relief angle, end cutting edge angle, side cutting edge angle, and nose radius. So this tool signature that I am showing right here on the screen, again they will be given directly without writing what they represent. So you have to remember in which order these angles are written, because this tool signature, as by the name you can guess that these are signature. So this will be just provide you every time the same order information. So every time the angle will be in this order or written in this way only. And to remember this ASA, one thing that you can do is remember that first rake angle is coming, then relief angle is coming, then cutting edge angle is coming. and then at last it is nose radius. And every time here side angle is coming second. So in every set side angle is coming second, so you can remember this whole thing, this whole signature easily by remembering first of all in which order the angle is written, and the other thing is that side is coming in the last of a set. So ORS is having first angle as angle of inclination, then we will have orthogonal rake angle, then we have this side cutting edge side relief angle, then end relief angle, then side cutting edge angle, then at last approach angle, then nose radius. So this is a little bit different. Here we have only one rake angle, that is orthogonal rake angle, coming in second, but first is the inclination angle, and inclination angle is equal to 0 for orthogonal cutting or machining, and it is not equal to 0 for oblique machining or cutting. So just remember this information so that if angle is 0 given, I is 0 given in ORS, the first term is 0 given in ORS, you get to know that it is orthogonal cutting by this information only. And then it is the two reliefs angle, but here the side relief angle is coming first, and then we will have the end cutting edge angle coming first, and then approach angle. Side cutting edge angle is not there, and then we will have this nose radius, which will be in mm. So this lambda, which is the approach angle, as I have told you before, that CS plus lambda will be, that is CS plus approach angle, will be equal to 90 degree. And if you don't exactly know that, or if it is not given in the question that what type of signature is provided, then you can just know the signature type by just seeing the penultimate or second last value. If the second last value is around 15 and 30, then you will just take it as ASA, because that is what CS range is. And if it is coming 60 to 90, something like this, then you will know that it is approach angle or principal cutting edge angle, and your whole signature is of ORS type. So this is one little tip or trick that I am providing you that you can use. Now let's discuss about this surface roughness. So I'm discussing it here only because it is not that hard. So if nose radius R is given, then the surface roughness or the peak valley to valley to the what you can say, the fall or the crest height will be h, then, or the roughness size will be provided by this h is equal to f square divided by 8r. So as you can see here, we are using nose radius, and the surface roughness is inversely proportional to nose radius. And here this is nose radius. So though both cutting edges are meeting at a point, and that point is having a curvature, how much curvature it is having is decided by nose radius, and it is directly proportional to f, that is feet. So this h, surface roughness, is inversely proportional to surface finish, because how much roughness, if roughness is more, then your surface finish is less. It is quite simple. So this h is surface roughness. I should just write it here. And this is surface finish. And let's talk about if no r is given, or if r is equal to 0, then what you will do to find the surface roughness, you will do this h is equal to f by, not f square, tan of side cutting edge angle plus cot of end cutting edge angle. So again, remember both of these formulas and make sure that you are remembering that which formula will you use when which things are given. So if r is not given, then you will obviously use this second formula, but if r is given, then you have to use the first formula to get the correct answer. So now let's talk about orthogonal cutting here. Let's do that revision also. Orthogonal turning, let's discuss that. So in orthogonal turning, we will have T is equal to F. So these are some relations. B is equal to D. The approach angle is equal to 90 degrees. The approach angle is or principal cutting edge angle, and the FC will be equal to Fz, that is the tangential cutting force, and the thrust force will be equal to the axial cutting force. So you will get this two things here, and this is whole is orthogonal turning. So orthogonal turning, this important things you have to remember, and also remember that I is equal to 0, angle of inclination is equal to 0. So that is also one relation that you have to remember. And let's now discuss about the other things in turning. So you have this chip thickness ratio. So chip thickness ratio is equal to R, and there are multiple formulas. It is first of all uncut chip thickness by chip thickness. So this is uncut and this is chip. Then we have this LC, that is chip length divided by the uncut chip length or uncut length. And then we have this chip velocity divided by the cutting velocity. So this will all be less than 1, because that's how we see the ratio is whenever we do machining, because due to plastic deformation your chip thickness will get increased, and therefore your denominator will increase, and you will be getting this value, this ratio less than 1. And I will just mention it here only, that to calculate angles in machining, that is alpha, beta, phi. rake angle, frictional angle, shear angle. To calculate these angles, you need first of all this formula, which is giving you the relation between the shear angle and the rake angle. So in most of the questions this rake angle is given, and you have to find this other two angles or any of the one of these two angles. So rake angle is given in most of the questions, either in tool signature form or in the form, or it is simply given directly. So using that value alpha, you can find the shear angle phi by this relation tan phi is equal to r cos alpha divided by 1 minus r sin alpha, where r is chip thickness ratio. And this is very important, and you will find that this formula is getting used in manufacturing question. In I think every year there is a question that is having this formula used in one way or another. So this formula is very important. Just remember this formula. And then the other thing that you can, other formula that you can use to calculate the angles is this tan beta minus alpha. It is equal to thrust force divided by the cutting force. So you can calculate beta minus alpha or beta from this equation. So this two equations, this equation 1 and this equation 2, so this 1 and 2 and questions data will give you all these angles. So this two angles, this three angles, one of the angle will be given in the question, and that is generally the rake angle, and other two angles can be calculated using this equation 1 and 2. So if you are able to calculate angle from this equation, then use this equations only, this geometrical thing only. And if you are not able to calculate the angle from this equation, if the data here is not sufficient, if for example there is no way of calculating r, that is the chip thickness ratio, then you can use Merchant's theory if it is recommended in the question, or if it is recommended that, or if it is given that you have to find for the minimum energy usage. So then you can use that Merchant theory, but don't use the Merchant theory if even if it is mentioned in the question, when you can calculate the angles from these two relations, because these two relations are coming from the geometrical the geometry of the tool, which will not change, which is more correct than the Merchant theory, because again Merchant theory is the theory and the geometry will be what you get, what is real when you are doing machining. So this chip thickness ratio is always less than 1, just remember that also. And let me show you Merchant circle now, because that will clear you where this second formula came from. Because the first formula is, you can see this first formula, and this formula is to be just studied, and you can just make sure that you are remembering this formula. This is also coming from tool geometry, but I don't think that we have to discuss in detail where it is coming from, because it is not yet asked. But the tan beta minus alpha, it we will see where it came from, because that Merchant circle is very important to study. So let's see. So let me just see, check out if I am missing something, because I have written here the topics in my front that I have to just mention during this class, because I don't want to miss any important details. So let me just check it out. So yes, I have covered all these things. Yes, there is one compression or reduction factor. Let me just also mention it here. So chip reduction or compression ratio, if something like that is given, then that will be the reciprocal of chip thickness ratio. That will be just reciprocal of all these things that is shown here. So that is chip reduction or compression ratio. And I think I have done one question, discussed one question in which this H was given, chip reduction or compression ratio, which came in one of the conventional paper of GATE. So just remember this thing, remember this detail, because chip reduction ratio is R. If chip reduction ratio is 1 by R, chip thickness ratio is R. So don't make the mistake of just interchanging them. So now let's discuss the merchant circle, and before that I think I remember that one thing that I have to mention is, so let's discuss this important thing: cutting shear strain, and this will be in chip. So cutting shear strain in chip in orthogonal cutting, this will be cutting shear strain is equal to gamma is equal to cot of phi plus tan of phi minus alpha. And again we have done some questions related to this shear strain, and in this class our main aim was to just quickly go through this formula, because I have done a lot of questions, but for this class I just want you to just relax, sit back and just see all these formulas that I am writing here, and just revise them, just remember them. Since the number of students watching this live is, I think nobody is right now watching this live, and what I planned was, if you were watching this live, then I was planning to just discuss with you this whole class, this whole formulas, so that I will ask you, then you will just write it down or just answer, so that your revision can happen in much better way. So anyways, I always recommend you to watch the classes live, and if you are not watching the class live, it is not that much fun to teach, and it is also for you not I think it is not better to watch recorded classes, because their interaction will be not there, and that interaction is very key in preparation in your online education. And here one important point that I will just cover is, if alpha is 0, then what we will get? We will get tan phi is equal to R. How we are getting this? We are getting this from this alpha is 0, this term will become 0, this term will become R, so this one will become 1, so this whole term will become tan phi is equal to R. So then what will happen? This gamma, that is the shear strain, will become 1 by R plus R, and 1 by R plus R, I should have written it like this, and 1 by R plus R is always greater than or equal to 2. You can just take 1 here, so you will be getting equal to 2. You can take 2 here, then you will be getting 2.5, that is obviously greater than 2. So just this term will be, this whole sum will be always greater than 2 or equal to 2 if R is equal to 1. So if alpha is 0 and this R is 1, then you will be getting this minimum value of shear strain as 2 if alpha 0 and r is equal to 1. And if r is equal to 1, then phi will be 45 degrees, because tan phi will be equal to r. So this thing you have to just remember. But the conditions here are for alpha 0, that is your rake angle 0, the minimum value of shear strain is 2, and that will only happen when r is equal to 1 or this shear angle becomes 45 degrees. So this might get asked in your GATE examination, but the condition that is most important for this minimum value of shear strain is that the rake angle should be equal to 0. So this is very important here, the condition that will lead to this whole thing. Now we were going to discuss the merchant circle, but there are quite few things that are left, so let's discuss that. One more here thing that I should discuss here only is the shear strain rate. So the shear strain rate will be simply shear strain differentiation of, or rate of change of shear strain with respect to time, and this will be given by the shear velocity divided by the thickness of shear zone. And what will be the unit here? It will be something, velocity's unit will be unit length per second, and it will be only length, so you will be left with this 1 by second unit, and this is thickness of shear zone. So that will be it for the discussion of shear strain and shear strain rate, and let's discuss about the different velocities in the machining operation. First of all, we have this cutting velocity. Then we have this shear velocity. Shear velocity, you have to remember one important thing, and I am going to just point it out here, that in shear plane, it is the velocity of chip with respect to workpiece, or I should write it so this shear velocity is in shear plane, and it is relative to the it is the chip velocity relative to the workpiece. So that is your shear velocity. And then we will have chip velocity, which is the velocity of chip over the tool face, rake face. So that will be chip velocity. And the relation between these three velocities is very important, and you have to remember that. So the relation is the cutting velocity, which is the velocity of tool with respect to workpiece, divided by cos of phi minus alpha. So this is equal to the chip velocity divided by sine of phi, and the shear velocity divided by cos of alpha. So just remember this equation, it is very important, and you are going to get some of the questions in which one of these velocities are given and the angles are given. You have to find the other velocity. You can also find the relation between this VC, that is chip velocity, divided by this cutting velocity, equal to R, equal to this T by TC, equal to the LC by L, and this can also be used to find this chip velocity if cutting velocity is given, and if you have means to find r. So I am not going to go in very detail how these formulas are coming from, because that obviously is not yet asked in the GATE examination. So obviously that is not the thing that we are going to consider, or just we are going to just focus here in this class, because here we should cover all the things that is required, important for GATE examination, and that is generally asked in GATE examination. So this equation is generally asked, and I have just shown you how to just relate VC and V. You have this chip thickness ratio also, and you have this other relation between this three velocities. So remember, both of this may come handy or may be useful in certain questions, so you have to remember both of them. So this R is chip thickness ratio again. So let's talk about here a little detail that I think should be useful for your objective type questions. So cutting velocity, if it is increasing, then micro welds will decrease, and friction therefore, because micro welds will broke off due to this increase in cutting speed, cutting velocity, and friction will decrease. So this might get asked in GATE examination, that how these terms are related. So just write this short brief detail that I have provided you in this manner only, so that you can just look into it and know what to expect if cutting velocity is increasing. Then what will be the effect in micro welds and the friction. So micro welds will be formed due to the high temperature of the cutting operation, again due to the losses of heat that is generated in the form of friction that will be there, and that high temperature will lead to some micro welds, and which will be just broke or just decrease, because not able to form because of this cutting velocity. And this cutting velocity or this friction will lead to just high temperature, and the built up edge forms due to temperature rise. So temperature rise leads to formation of built up edge. So that thing will also be decreased if cutting velocity is increased, because again this friction and micro welds will not be forming. So but one thing you have to just remember, that cutting velocity is also making temperature rise. So in some manner cutting velocity is also leading to this micro welds, because cutting velocity if increasing, I have discussed it during one of the slides in this class, that if cutting velocity is increasing, then you will get this high temperature due to high power generated, because power is equal to force into velocity, and that force will be cutting force, and that velocity will be cutting velocity. So cutting velocity will leads to this temperature rise also. So you have to be very careful that what you have to answer, because built up edge formation is formed due to temperature rise, but the temperature is rising with cutting velocity, so it is in one way making this built up edge occur. But also at the same time micro welds are decreasing, friction is decreasing, and then you can say this built up edge is also having some decrease or reduction effect due to this thing that the cutting velocity is doing. So these two effects are there that you have to just consider due to the cutting velocity change. and then we have a serrated chip. So serrated chips are the one which are having their chip thickness different as the chip is produced. Its length will have different chip thickness due to shear strain being different in different sections. So shear strain is proportional to chip thickness, and therefore we will have this different chip thickness, and the chip will look like something like this. Your chip will look like. So as you can see, the chip thickness are different, and the different chip thickness reason is that shear strain in the locations of in the different regions of chip are different. So this is your serrated chip. And here let me just quickly show you. This is your tool. This is your workpiece. Your tool is moving in this direction, and this right here is the shear plane. So this shear plane and the velocity will make some angle, the cutting velocity, and that angle will be the shear angle. So that shear angle will be the angle between the shear plane and the cutting velocity, and this right here is the thickness. Uncut chip thickness will be equal to the depth of cut. So this TS, which will be the just this thickness of the, or the length, or you can say thickness only, thickness of the shear plane will be T by sine phi. So your area, if this is the width of the chip or of the workpiece, then this area of shear plane, this area of shear plane, this will become BT divided by sine phi. And how it is becoming that, I hope you can clearly see in the figure, and you can just remember that, because this is a revision class, so I expect you to study if you have studied this before. So let's just discuss now about the merchant circle. Let me show what are the things that are left. So there are nothing very long that is left. We are just left with the merchant circle discussion. Then we will discuss about the Taylor's tool life equation and the optimum tool life for minimum cost, and also we have to discuss about the merchant's theory. So these are some of the things that is left here, and after that we will just end this class, and in the tomorrow's class we will discuss about metal forming, do its revision there. Quickly we will do the revision of only formulas and little bit of things that are required in theory, but mainly we will do the revision in which we will focus in formulas and how to do numericals, because that is one thing that is going to be focused, because I don't want you to just mix all the theory and numerical thing together, and don't so that you are not prepared with numerical also and also with the theory. So I want you to just focus on numerical and prepare and revise them fully, and theoretical class you can just see your notes, because that is there not so much, so I will not cover that again, because I have covered that in the my important question classes. I have selected the numericals and the theories that have covered a lot of topics in the metal forming, so a very less amount of things are left and which are not that much of importance, but still you should study every topic at least once, so that you have the idea when you are going to solve questions. So let's just discuss about merchant circle here. So this circle will I will just write to find forces F frictional force, N reaction force on the friction surface or the tool surface, and we have cutting force, thrust force, shear force, the normal force on shear plane. So to find these forces and to find angles, this merchant circle is very important, but we have to remember some of the things from this merchant circle so that we can use them without drawing the circle or without drawing this whole thing again. And I will just tell you which I think there is only one or two things that you have to remember here, two things that are in that are asked frequently. So first of all, let me just make this figure. So all the six forces will be shown here in the diagram that I am drawing, and this diagram will be very important for your calculation of these forces, and by using this you can calculate the forces. There are some relations that are obtained from this diagram and that we have to just see, but there are some other ways, other formulas by using which you can just also get the forces, but I don't recommend you to learn that, because I don't want you to just learn the things that are very lengthy and that you will have a difficult time in remembering. So I don't recommend that. So I recommend you to find, if the question is asking you to find forces and to find angles, then use this merchant circle only. So here let me just show you which are perpendiculars here. So this is a perpendicular angle, as you can see. This is also perpendicular and this is also perpendicular. And now let's write the forces here. So here we have shear force, here we have normal force on shear plane, then we have this frictional force, normal force again on frictional surface, and we also have this cutting force and thrust force here. And here we have resultant force, which is common for all this sets of forces will have this common resultant. So the sets of forces are this, and this. And let's draw now the angles here. So this angle is phi, which is the shear angle. This angle is beta, the frictional angle. And we have this tool here, single point cutting tool, and this tool is making this angle alpha with this reference plane that is vertical. So this tool's face is making that angle alpha with the reference plane is rake angle, and you must know this because we have discussed it. So this whole geometry you have to completely remember. And one more thing that you can remember, which you can also find out, is that this is beta minus alpha. This angle is beta minus alpha. I should write it a little bit properly here so that it is clear. Beta minus alpha is this angle, and this whole angle is 90 degree. So from here there are some multiple things that I want you to just remember. So the things here that I want you to remember are, first of all, resultant will be equal to first of all I will write it here. The resultant R will be equal to under root of FC square plus FT square. It is also equal to under root of Fs square plus NS square. It is also equal to under root of F square plus N square. So this is the resultant R that is here. And if you want to calculate Fs, and if only you have this resultant R and some angles, if you don't have this Ns, that is the reaction or the normal force in the shear plane, then R in this triangle, which is made by this shear forces Fs and Ns, and this resultant, we have this whole angle here, beta minus alpha plus phi. So R cos beta minus alpha plus phi will give you Fs, and this is very important because this gets asked in GATE examination. And after calculating Fs, it is generally asked that you have to calculate the shear strength, and that will be Fs divided by Bt divided by sine phi, which is the area of shear plane. So these things you have to remember that I am showing right here on your screen. And other thing, I have also shown that tan beta minus alpha is equal to Ft by Fc, because a lot of time that is what is given in the question. And here I have also shown the relation, and that relation is coming from this Fc, Ft and R triangle. Here the tan beta minus alpha will be Ft divided by Fc. So this again is very important, and you have to remember this equation because this gets asked in I think every year or two this gets asked. So you have to remember this to calculate beta specifically, because alpha will be given in the question. And Ft and Fc are usually also the forces which are generally given. So There are other ways also, but this is the most fastest way. And the things that I have shown here, you have to remember. Don't just do all this figure drawing, then derive, or just then see the formulas from that figure. Just remember the formulas that I have made a star on, because they will be important. And if you are drawing the figure, then you will be losing some time, which is not I think recommended, because these are some standard figures, formulas that you should know. And a lot of students will just remember this formula, so I expect you to also know this, that these formulas are to be remembered. So let's move forward, and I hope this, and if you draw a circle around this whole thing, you will find, so if you draw a circle around this whole thing, you will find that the merchant circle is completed. But I am not going to draw this, because that will obviously make this whole thing more complicated. I'm just going to mention that, and let's move forward with the discussion here. So I should have to just add some slides. Let me do that. So let's continue some things that are left, then we will end this class. So the things that are left are, so yes, merchant theory, let's discuss that. So very few topics are left for the day, for our today's discussion. So merchant theory. So merchant's theory is nothing but phi is equal to 45 degrees plus half of rake angle, and then half of frictional angle. So this will also be in degrees, because 45 degrees is there, so put them like that, and you will be getting this whole angle as the shear angle. So this will give you a shear angle, which will be, so the merchant shear angle will be greater than the actual shear angle. And if shear angle is greater, then you can see that your shear plane is, if shear angle is greater, then the shear plane will be smaller. The shear plane will be smaller, because what happens is that this shear area of shear plane is bt by sine phi. So if phi is greater, then this whole term will become smaller. So this will lead to less cutting force, less power, so overall less energy consumption, less power usage, and less temperature therefore. So this will give you that minimum energy usage and minimum power usage, or minimum temperature. Merchant theory is giving you that. So if you have that asked in the question, then you have to find merchant theory. If this geometry, this angle that I have mentioned, that this angle, first you have to find that. If you are able to find the angles using these two formulas, if you are able to do that, then always use this formulas first, because they are derived directly from the geometry. And if you are not able to do the calculation of angles using those two formulas, then you are going to use the merchant theory if it is given in the question. So Taylor's tool life equation, that is also very much an easy theory or easy formula. So that is Vt raised to power n is equal to C. And remember here, the most important thing is that V is always in meter per minute and T is in minute. And if you are just not writing or not putting this in this units, then you will not get the correct answer, because the C that is given in the question or that the examiner expect you to calculate will be only possible when you use this units. So use this units only. And we have this other formula also. So if feed and this depth of cut is given, then they are related by this then the tool life equation will become this, and you have to consider them. So this is also one of the equations that will come in handy. And let's discuss here one more thing, that if optimum tool life for minimum cost is asked, then it will be T naught is equal to 1 minus n divided by n. Inside bracket we have Tc plus Ct divided by Cm. This Tc is tool change time, this Ct is tooling cost, and this is in rupees per minute machining cost. So again you have to remember this machining cost, this is rupees per minute, this Tc is tool change time, and this 1 minus n by n, and this is for optimum tool life for minimum cost. But if optimum tool life is asked for maximum production, then it will be 1 minus n divided by n into Tc. It will be this simple. So again, this optimal tool life, when you will get, you can use this in this Taylor's tool life equation to get the optimum velocity for that condition. So that will be it for the discussion here of optimum tool life where formulas and also the Taylor's tool life equations. So let me just give 1 minute. Let me just I will be back after some minute here. So let's just conclude our class here. So the last thing that we have to discuss is this center line average, which is equal to h by 4, where h is surface roughness, and what I just discussed about surface roughness, it is f square by 8r if this nose radius is given, or if it is not given, then it will be f by 10 of side cutting edge angle plus cot of end cutting edge angle. So that will be the formula of this surface roughness, and if we divide by this 4, then we will get center line average. And one of the GATE question has already asked from this formula, so you have to just make sure that you are remembering this little things also, because this was not asked before 2019 or 18's GATE, but it was asked there. So you have to remember and study all the things that I have already just informed you, because from the GATE syllabus anything can be asked. If it is not asked till now, then there is still possibility, so you have to cover them at least once. And specific energy consumption is equal to E. This will be equal to power divided by the material removal rate, and its unit will be joule per mm cube. So just remember this, and here MRR will be in mm cube per second, you can remember that also, and here power will be in watt. So this will be your specific energy consumption E. And we have specific cutting pressure, which is also sometimes this only. So specific cutting pressure can also be, you can also remember this, because sometimes specific cutting pressure is given with the units joule per mm cube, but sometimes it is asked in the simple megapascal unit. So specific cutting pressure this will become the cutting force divided by FD or BT, that is the area of cut. So this will be in the normal units of pressure, megapascal or Newton per meter square or Newton per mm square. So that is the pressure's unit only. So remember these things. So yeah, these two things slides we will not be requiring. So since today also I don't think right now any student is watching, so I should just end this class. I have covered a lot of things, a lot of formulas we have revised today. So that's it for today's class. And if you want to follow me, then you can follow me on unacademy.com. just paste this link, write this link on the browser of your, and just visit my profile there and follow me. Then you will be given all the notes that I have taken, PDF notes. You will also be provided there free classes that I am just taking on unacademy.com. I will be starting thermodynamic important question there, and also you can find important tips and tricks class and other revisions there. And there the interface is far better, and there I only take 1 hour class in each session, so that is also not that long. So you can take that time and attend the classes there. I take classes there 10 p.m. And you can just visit there and follow me, and my schedule will be visible, what topic I am teaching in which day. So you can attend the class if you are feeling like attending that class topic. So just follow me, and just make sure that you are using this code ABHIMI to get free classes on Unacademy app and website. To check what Unacademy app and website looks like, what features they are offering. To also join Unacademy's GATE Combat, you have to use the code. So just use this and just get this free classes and just take benefit from them, just learn from them, and also get the use this code to just join Unacademy's subscription and get 10% off. And before just ending this class, let me show you Unacademy's GATE Combat one more time its video, so that you get aware what it is if you have not watched it before. So if you have not watched the Unacademy Combat video that I have shown in the starting of the class, you can watch it here. I am showing it right now.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So that was Unacademy Combat, which is starting in the video. It was not written correctly. It was it will start 16 December, so you can register there, and at 6 p.m. it will start, and use this code to join the register in the Unacademy's Combat quiz and win prizes. So you are getting best of both world, also getting done your preparation, and also getting prizes if you score good marks, if you score good rank there. So it's a win-win situation. So just take part there and use the code ABHIMI to do that. Use this code to get free classes on Unacademy, to download notes also, and as I've discussed, to join the Unacademy's GATE Combat, and also to get 10% off code if you are planning on subscribing to Unacademy, which you totally should, because there are 2 months left and you should be joining Unacademy's Combat and the Unacademy subscription, and just watching all the crash courses to learn in this 2 months, to prepare in best possible way, to learn as much as you can. So that will be it for today's class. Thank you for watching this class, and hit the like button if you found this class helpful. If you found something important that I have taught you, that you have just got benefit from, then hit the like button, and just share this class if you want to, so that more students can come here and we can all study together, discuss together. It will be nice environment if we all study, because there all the students will be getting more different benefit if more students are watching, and also I will be having more fun and engagement during the class, so that is always good. And subscribe to this channel and hit the bell icon for notifications, and whenever an educator goes live, we will be getting notifications. So to do that, hit the bell icon, and I will go live at 2 p.m. for manufacturing, and I'm planning to take thermodynamics, which I'm planning to take in the evening. So let's see if I will get that time slot or not. So again, thank you for watching. Best of luck for your preparation. Stay safe, take care. That's it for today's class.